Okay, so let's start today class. Today we are going to discuss new topics. That means speed torque characteristic of the motor. Okay, so today just discuss basic whatever you maybe electrical machine study in the previous semester. So I think characteristic of all the motor, that means DC or AC, that means induction motor, you maybe already study in previous semester. Okay. So a speed torque characteristic of various type of motor. Why we require the basic what is the concept and basic parameters for the electric drive purpose. Okay. So the parameters of a motor can be easily obtained from the speed torque characteristic. If you know the speed torque characteristic of particular motor, then other parameter you may be easily obtained. Okay, which type of motor you require to use for particular load drives and their control circuit. Okay, so it is necessary to know the torque to be delivered and the speed at which the machine you want to drive. Okay, in order to obtain the desired for that desired output. So it is also possible to predict the performance of motor. If the motor circuit or loading condition are changed as required, torque may be acting in one direction under a certain situation. But when the act in the opposite direction, as the situation change, okay, the direction of rotation may also be changed accordingly. So you have to basically, first of all, concern which type of load you want to drive, which type of motor you required for the suitable their speed control and other parameter. How can you find out? Okay, so basically we study here the various type of motor characteristic of a speed and torque, how they can change. Before that we are going to discuss just to share the screen, then we will continue. Okay. So first of all, a speed torque characteristic for the various motor, if you want to require. So is it clearly visible? Hello?
Yes, sir. Yes, sir.
Okay. So today we are going to discuss a speed characteristic of various type of motor. Okay. So we require their speed characteristic because we want to drive some particular load by the electric motor. So how we can control their speed and other parameter or the desired output. Okay. So for the motor selection or their speed, we just try to discuss about this, some types of load. Okay. So types of load, can you give me any example of the uh, sorry, fan load characteristic, speed torque characteristic, how they can relate it? So the types of load, that means if you consider the fan load, okay. So fan load requires the vary speed is directly proportional to the torque is directly proportional to the square of the speed. Okay. So the positive load torque is opposite in direction to the positive motor torque. The load torque maybe remains constant or maybe practically independent of the speed. We are talking about load torque, not torque, electromagnetic torque developed in the motor. Okay. So concerned about this point, the load torque either may be constant or practically independent of a speed of the motor with some of the power of the speed. So if you consider that fan load torque, that means the square of the speed. So this is the characteristic for the fan load. Suppose that this is your T represent as the electromagnetic torque developed in the motor. Okay. And one more thing we here discuss one point for that this characteristic. That means we try to discuss their electromagnetic torque development direction, which direction we have to consider positive, which direction we have to consider negative, and a speed of the motor. Okay. So more conventionally, we consider the rotation of motor in anti-clockwise. So that torque we consider as the positive. Okay. And clockwise direction that we consider as the negative. So as you know that the electromagnetic torque and load torque always acting in the opposite direction. So and their characteristic speed may be in the reverse direction, torque produced in the another direction. Okay, so we just consider the speed torque characteristic in all the four quadrants. Suppose if you consider that in first quadrant, that means along the x-axis we consider the torque, and along the y-axis we consider the speed. Okay, so if characteristic discussed in the first quadrant, that means torque and speed both are in positive direction. Okay, if you consider the characteristic in suppose that here, so that means the torque in acting in the opposite direction. This along this side torque is negative. Suppose if you consider that along this side x-axis of positive, so reverse along this direction torque will be negative. Okay, so in this direction torque acting in the negative direction and speed is positive. Suppose we consider the characteristic in the third quadrant. Okay, that means torque as well as the speed are in opposite direction of the first convention, that means in clockwise direction. Okay, and if you consider in the fourth quadrant, that means torque is positive but speed is negative direction. Okay, so we try to discuss all the four quadrants. There one example, with the one example I will explain later, but here we consider the fan load characteristic. That means torque is directly proportional to the square of the speed. Okay, so their characteristic is similar to like this one. So this is your direction of electromagnetic torque developed in the motor in the anti-clockwise. So speed is also in the same direction. First one. Okay, so in the anti-clockwise direction, but load torque acting in the opposite direction of the electromagnetic torque. Okay, so their direction I have here shown in the opposite direction, that means in clockwise direction. Okay, and another types of load, we can say that the friction type of load. Okay, constant friction type of load. That means friction torque oppose the rotation, actual rotation, where we try to rotate the motor. So whatever the friction torque exists, that will oppose the actual motion of the motor or actual drive direction of the load. So it is independent of a speed.
Sir, friction,
Yeah.
friction and windage loss will oppose.
Sorry.
Friction and windage loss will oppose the speed of rotation.
Yeah, friction loss is always act in opposite direction to the actual motion speed drive. Suppose that we just walk on the surface, then we want to move in the forward direction, but friction exists in the reverse direction, our reverse direction. So whatever the friction
Yes,
force, friction torque, that is always opposing direction to the actual motion, is it not? Friction force is always in opposite direction to the actual motion. So this is the basic concept. Friction is always acting in the opposite direction to the motion. Is it not? Hello?
yes, sir. Yes, sir. I got it, sir.
Okay. So friction force is always act in the opposite direction of the actual motion. Yeah. And that will be independent of the speed. So it is very small during a normal operation. So friction at the time of starting may be considerable. At the starting point, more friction torque here compared to the running motion. So almost is negligible when in the running condition. Okay. So if the drive is started frequently, that means machine is fitted with the some form of the ball or roller bearing. That means we can say that friction force is always act in the opposite direction of the actual motion. At the starting point, it is more compared to the running point. Okay. And next type of load is your dynamic or inertia. Dynamic and inertia. So when the speed of rotation mass is changing, dynamic torque or inertia torque acts in the opposite direction against the motor torque. So just we try to understand with the help of this figure. So yeah, dynamic or inertial load. So suppose that this is your motor, okay, and with this shaft you want to just drive one drum or a roller. You can say that the roller have the some mass that is represented by here drum, okay, and with that drum you just one belt hang on the drum, so you can drive the load. Okay, when the motor of the shaft is rotating in this direction, so drum or mass, whatever you connected with the shaft of motor, this one also rotate in this direction. So whatever the load you have hang with this uh, belt, so just try to in the upward direction. Okay, in the upward direction. So their drum inertia is represented here JD. Okay, and the motor inertia is represented as J represent for the inertia. Okay, M and D represent for the motor and drum. Okay, so when the speed of rotating mass is changing, so dynamic torque or inertia torque acts against the motor. So this torque is represented in mathematical equation. That means J d omega by dt, where J is your equivalent inertia. That means equivalent inertia of all the rotating mass. That means motor as well as the drum. Okay. So these are the basic types of load. That means which are the load act when you drive any particular load. Okay. And next we want to discuss four quadrant of the speed torque characteristic. Okay. Four quadrant speed torque characteristic. So first, in first quadrant, we can say that the consider as forward motoring mode, and second quadrant, that means forward braking mode. Okay. So these are the characteristic of the speed torque in the fourth quadrant. Okay. Yeah. So just I explained the speed torque direction in the previous figure also. So here you can consider all the four quadrant. How we can speed is positive, torque, electromagnetic torque is negative. Okay. So in the first quadrant, that means when we explain first quadrant speed torque characteristic, that means torque, electromagnetic torque, as well as the speed in anti-clockwise direction. Okay. So suppose that this is a pulley. Okay. And you want to some load lifted in the upward direction with some particular speed that is represented by omega. Okay. So motion of this load you want to in the upward direction. So motor torque will act in which direction? In, if you want to this load in the upward direction. Okay, since we are discussed here in the first quadrant, so motor torque and speed
Yes.
are in positive direction. That means we can say that the rotation in the anti-clockwise direction we consider conventionally positive. Okay, so motor torque, electromagnetic torque act in the anti-clockwise direction and speed in the same direction. Okay, that means in anti-clockwise direction. So this is the counterweight. That means if you uh, place some weight more than this one, so this load may be lifted in this direction. So what is the load torque acting? Load torque acting in the opposite of the motion. So motion is the upward direction. So load torque acting in your clockwise direction. Okay, since the rotation of this pulley in anti-clockwise direction, so load torque acting in the opposite to the electromagnetic torque, whatever the torque in the okay. So this is the torque direction we can represent in the first quadrant. Okay, and in the second quadrant, that means torque in opposite